Math 3, Unit 10, Section F. Today we're going to be talking about turning radians into degrees or degrees into radians. Okay, so we're going to end up going through the unit circle, changing all of them, seeing if there's patterns, all that kind of stuff. Okay, but we're going to do that later. Today I'm going to start by giving you the values here, and then you'll see how I got them. Does that make sense? Okay, so we know 360 degrees is 2 pi radians. We also know that 180 is 1 pi radians, or just pi radians. Do you guys remember what 90 is? Half of 180, right? So that would be pi over 2. Okay, now these other ones I'll go through and kind of teach you about them later, but 60 is pi over 3. 45 is, guess what it is? Pi over 4, but then 30 is pi over 6. Okay. So if you're ever wanting to convert between radians degrees, if you remember that 180 degrees equals pi radians, the way you end up converting is 180 divided by pi. And I'm going to kind of show you what happens here. So when you're converting from radians to degrees, you multiply by 180 over pi. If you want to go from degrees to radians, you multiply by pi over 180. So just to kind of work from the formula we talked about before, which is circumference. So circumference equals 2 pi radians. I don't know what just happened. And we know, or sorry, 2 pi r, and we know that we have 2 pi, and our radius for all of these is 1. And so the whole circle is 2 pi radians. So if I know that 2 pi radians equals 360 degrees. Okay, is everybody okay with what's happened here so far? Okay, so 2 pi radians equals 360 degrees. If I just want to get 1 radian by itself, okay, I would divide both sides by 2 pi. So what that tells me is that 1 radian equals, and we can reduce, and so we get 180 over pi. So that's where the formula has come from. And then you can go backwards. And so radians and degrees, they're just flipped from each other, depending on which way you're changing them. So right here it says convert each angle from either degrees to radians or radians to degrees, whichever is appropriate. So here we have 11 pi over 12. So that means we're going to change this from radians into degrees. So all you do is take 11 pi over 12 and you multiply it by 180 over pi. And I remember that this one is the 180 over pi because I want my pi's to reduce. I want them to cancel out. Where the other one is going to be pi over 180 because I want to keep the pi. Make sense? Okay, so here my pi's cancel. 12 goes into 180 15 times, good. And 11 times 15 is very nicely done. So 165 degrees is the answer. So 11 pi over 12. Did I do that right? I think that multiplication's wrong. Hold on. 11 times 15. Yeah. Okay, just kidding. That's right. And if you think about it, remember on here, okay, this would be 24 pi over 12, correct? And then over here, this would be 12 pi over 12. So, so it would make sense that 11 pi over 12 would be in quadrant 2 and is 165 in quadrant 2. So that's just meaning that at that point, 165 and 11 pi over 12 are at the same point. And remember, one is talking about the degrees and one is talking about the arc length. Okay, so now if I want to change 330 degrees into radians, what would I do?
You would do it backwards and multiply by
Very good, pi over 180, because I want to end up with pi. Okay, and so first of all, I know if two numbers end in 0, I can cancel those out. So now I have 33 and 18. What can go into both of those? 3.
Oh. I was thinking.
So that's 11, and that is 6. And so we end up with 11 pi over 6 radians. Okay, any questions? Okay, so I want us to get more practice with these. And so we are going to change each of these into degrees. Does that sound okay? All right. And normally when you're finding sine, cosine, and tangent, those are of degrees. So you really do need them into degrees. Some of these are ones that we actually know based on what I told you in that table above, but let's just make sure that we understand how to convert. Okay, so we're going to take pi over 6 times, and what am I going to multiply on this one?
180.
Over pi, good, because we want our pi's to cancel out. Okay, so pi's cancel out. 6 goes into 180. Very good, 30 times. So that means that this is the same as 30 degrees. Okay, so if we go ahead and all they've asked is to sketch the reference angle, but it's kind of up to you. Sometimes it's easier to draw the original first. In this case, our reference angle is the same as the original, right?
Mm-hmm.
Okay. Okay, so that is 30 degrees.
So when you have like a fraction with pi, you want to get rid of pi, but when you have like a degree, you want to keep pi.
You want to bring pi into
Yeah,
it,
bring pi
basically.
in.
Yeah, or
Okay.
keep it. Yeah, that works.
You mean by the reference angle and like the standard or whatever? But if it was like a quadrant 2, you'd only just draw like.
You could just draw the reference angle, but I'm okay with you drawing both.
Oh.
I think it's easier to draw both. Okay, so there we go. And so once you have your reference angle is where you're taking sine, cosine, and tangent, correct? And so I would probably take out my unit circle. So sine of theta, and then we have cosine of theta and tangent of theta. So we remember that sine is dealing with the what? Good. Cosine is dealing with the x, and tangent is y over x. So if you go to your unit circle, we know the ordered pair at 30 degrees is what? Good. And we're okay with using these because we know how to make the unit circle how it is right now, correct? And if you don't, you need to make sure you understand that and come in for extra help at lunch or watch my video that I posted on writing or making the unit circle. Okay, so that means my answer for y for sine of theta is what? 1/2. Cosine is root 3 over 2, and tangent is? So tangent is always y over x, right?
Oh, so
1 over root 3, which means we will write that as root 3 over 2.
Wait, isn't it root 3 over 3?
Yes. Oh my goodness. I didn't even have any oranges. Okay. All right, are we good? Okay, next one. Let's change that into degrees. So we have 3 pi over 4 times what?
180 over 4.
Good, 180 over pi. We can reduce there, so the pi's cancel. 4 goes into 180. Very good. And then 45 times 3 is? Good job. 135.
Oh,
Okay, so we draw a reference angle. Which quadrant will it be in? Or our standard, whatever. It's in quadrant 2. Okay, so that's 135. But our reference angle always goes to the x-axis. So since I'm looking at the degrees, I'm trying to figure out what does it take from 135 to get to the x-axis? What does it take to get to 180? And what is that? 45, right? But we can actually look even on our unit circle and it tells us as well. What is my ordered pair at 135 degrees?
Negative root 2 over 2.
Good, negative root 2 over 2 and root 2 over 2. So we have our sine of theta, cosine of theta, and tangent of theta. Okay, so what is my sine?
It's your y's.
It's your y. Good.
Root 2.
Perfect, root 2 over 2. And I noticed on your quizzes, a lot of you were forgetting negatives and positives, so be careful. Okay, cosine of theta is negative root 2 over 2, and then tangent is y over x, and so we would end up with what? Very good. So, or not, the y is root 2, and the x is negative root 2, correct? So what happens with that? Do these cancel out? Can I cancel out root 2 and root 2 like this?
Yes.
Yes.
So it's 0 or
Negative 1. Okay. We good? Why don't you guys try this next one on your own? Okay, what degree did you guys end up getting?
240.
Good. So these cancel. 3 goes into 180 60 times, and 240 degrees is correct. So which quadrant is that in?
3.
Very good. Quadrant 3, right here. And so we're trying to find our reference angle. So if this is 240 degrees right here, how many degrees does it take to get to 180? 60. So the reference angle there is 60. Okay, so remember, you're always going up to the x-axis. You're trying to figure out what does it take to get to 180, or what does it take to get to 360. Okay, does that make sense?
Yep.
All right, so what is your ordered pair at this point?
Negative 1/2.
Okay, negative 1/2.
And negative root 3 over 2.
Good, and negative root 3 over 2. So sine is always dealing with
Y's.
my y, and so this is going to be,
Negative root 3 over 2.
very good. Cosine is dealing with the,
X.
and so that will be
1/2.
good. And then tangent is y over x, and so we would write that as
Negative.
3 over 1, or just root 2.
negative root 3 over negative 1, which reduces to just be good. Okay, good job. Do you guys feel okay with that?
Okay, wait. I'm kind of having trouble understanding the tangent, like how you get it.
Okay, so when you're finding the tangent, you are only looking at your numerators.
Oh, okay.
Okay, and because your denominators would end up canceling out because they're the same.
Okay.
And so when you're doing y over x, it's only your numerators.
Okay.
And then reduce. So if you have a root in the denominator, you'd have to rationalize and that kind of stuff. All right.
Thank you.
You're welcome. Okay, back side. Okay, so same thing here, same instructions, but you'll notice that these are now negatives. So sometimes it makes it slightly more complicated. The first thing I always do is kind of forget about the negative for just a minute. We can go ahead and change this into the degree form. So pi over 3 multiplied by 180 over pi, and what do we end up with? 60 degrees is correct. Okay, but we know it's not actually 60 degrees, it's going to be negative 60 degrees. Are we good with that? And so when we go down here, it's going to be going into which quadrant?
4.
Very good, quadrant 4. Okay. So here we are. Now you have to basically figure out either what degree is this at originally, or where is negative 60 degrees. But what would be my ordered pair for that?
It would be negative root 3 over 2. No.
The ordered pair
300.
is going to be 1/2. Good. It's at the 300 mark. That's correct. Okay, so 1/2 and negative root 3 over 2. Now, let's say you're having a hard time figuring it out. Could you just draw this, since you know this is 60 degrees, could you go through and just actually do the work and find the angle and all that stuff? You could. So if you're ever confused, just do that. Okay, so then same thing. So at this point, what will be my sine of theta? Negative root 3 over 2. Cosine of theta will be 1/2. And tangent of theta will be what, Jordan?
Tangent of theta will be negative 3 over 1.
Negative root 3 over 1,
Negative root 3 over 1.
which will reduce to just be negative root 3. Perfect. Okay, points of confusion.
The third one on here is not negative. Let's change to negative.
No, we'll leave it that way. It's fine. But if you notice these ones down here that we get to, these are going to all be different. Okay, just so you know. Yes, Jordan.
So since theta is negative, once you get your angle, then you just make that negative.
Yes.
Okay.
Okay, so negative 3 pi over 4. Are you guys already changing that? Okay, so 3 pi over 4 times 180 over pi. Pi's cancel. 4 goes into 180. 45 times. We multiply 3 times 45 is 135 degrees, and that is a negative. There could be some answers on your test that you get a decimal. Okay? It's okay. When you're converting. So negative 135 degrees, what quadrant will that end up being in?
30.
Very good. 3 is correct. Just to make sure, in case some of you are struggling with that, I know that positive 135 would go to quadrant 2. And so I'm going backwards. So I have to go backwards 1, 2, and that's how I know that I end up there in that quadrant 3. Okay, and so then we have our reference angle. But this isn't at the 135 degree mark. This is why you have to kind of think if you're looking at your unit circle. But 135 to the 180 is how many degrees? 45 degrees. And so we know it's the 45 degree angle mark there. And if you go 180 minus 45, it'll take you to, or no, sorry, 180 plus 45, it'll take you to the mark. So what is this order pair?
Negative 2 root 2 over 2, negative 2 root 2 over 2.
Okay, good. Okay, negative root 2 over 2 for both of those. Okay, so sine of theta is?
Negative root 2 over 2.
Good. Cosine of theta is?
Negative root 2 over 2.
And then tangent of theta is? And it ends up being positive 1, because you'd have negative root 2 over negative root 2, which reduces to be positive 1. Okay. This next one, it's the same idea. We've already been doing it, so we're going to go ahead and skip that. Is that good? Okay, so this first one down here is that, and you're going to cross those out, theta equals pi. Okay? So where is pi?
It's at the one.
It's at 180. You guys might already have that memorized. Okay? So it's right there. Okay? That is where pi is. And what mark is that? What point?
Oh, it's
What order pair?
negative 1, 0.
Very good. Okay, and so now we're just going to find sine of theta, cosine of theta, and tangent of theta. And you know what? I probably should not be putting theta there. I probably should be putting my degrees, like 180, whatever our degree mark is, but we're just stating that theta's that. So anyways. Okay, so what is sine? Okay, sine is always dealing with the y, so therefore it'll be 0. Cosine is good. And tangent, when we put 0 over negative 1, because it's y over x,
Undefined.
it'll be 0. When is it undefined?
With 0 on the bottom.
Good. Under, 0 under, undefined. Okay, got that? All right. Okay, next one. This one, I'm going to tell you that theta equals 6 pi. Okay, so we know that each half circle is 1 pi, correct?
Yep.
So if we have 6 pi, and if you want to, you can just count. Okay, so that's 1, 2, 3, 4, 5, 6. And if you think about it, 3 complete rotations would be 3 2 pi's, right? Which makes 6 pi. What is the ordered pair at that point?
1, 0.
Very good. 1, 0 is correct. So we have sine of theta, cosine of theta, tangent of theta. I always like to label these as x and y to kind of help myself out. If you want to go through and write these as sine is y, cosine is x, tangent is y over x, that can be helpful too. And so what is sine of theta?
0.
0. Cosine is 1, and tangent will be 0 because we get another 0 over 1, which is 0. Okay, this last one is going to end up being pi over 2. Where is pi over 2? The 90-degree mark. Because remember, if this is pi, this is the halfway mark. Okay? And so that is where pi over 2 is. What is that ordered pair?
0, 1.
Very good. 0, oops, 1. So let's write this one the correct way this time. Sine of 90, cosine of 90, tangent of 90, because that is our 90-degree mark, correct? And if you weren't sure that that was 90, could you plug it into your formula?
Yep.
Yes. Okay, so what is sine going to end up being? 1. Cosine? 0. And tangent will be?
Undefined.
Very good, because the 0 is under. Under is undefined. Okay? Any questions? Okay. So this just says find the ordered pairs on the unit circle for each angle. So if you have 11 pi over 6, you have a couple options here of solving this. How would you guys want to find it?
Let's do the first type we did.
The converting to degrees? Okay. So converting to degrees, all we do is go 11 pi over 6 times what? 180 over pi. We can reduce here and here. 6 goes into 180 30 times, and 30 times 11 is 330 degrees. So they have it drawn for you here, but do you notice how this is the 4th quadrant? So 330 degrees would be here, or this could also be 11 pi over 6. Okay, but what is that ordered pair there?
It is
Root 3
root 3 over 2.
over 2.
Root 3 over 2,
Negative
-1/2. There's your answer. That's all they wanted, was the ordered pair at that point. Okay, last one for a review. Similar to the quiz question. So if this is 8 over 17, that means we want our denominator to be 17, so what would be my hypotenuse?
17 over 17.
17 over 17. So we need to find this x side. Okay, how am I going to find it? Good, but when we're using Pythagorean theorem, we're not worrying about the denominators because we know all of them would be 17 and we're just looking at the numerators. So when I set this up, it'll be what?
64.8
Plus x squared, or however you do it, equals,
17 squared.
good. And 8 squared is 64 plus x squared, and 17 squared is?
289.
Very good. We subtract 64 to both sides. X squared equals, and what's that square root?
15.
Plus or minus.
Very good. It is plus or minus 15. So we need to decide, will it be plus or will it be minus?
Minus.
Minus. Why will it be minus?
Because it's quadrant 2.
It's in quadrant 2. Very good. And so that's going to be a negative 15 over 17. And so what is the ordered pair? Negative 15 over 17 and 8 over 17. Okay, any